Und jetzt kannst du jetzt wieder machen. Jetzt ist es der CX, das ist dieses Ding hinter dir.
Ja, so schon angekreuzt.
Genau, richtig. Ich glaube, die hören uns auch schon. Und Video kannst du auch noch den auswählen, wenn du Video willst.
We can see you and we can hear you.
Ja, stimmt. Man sieht uns da oben auch schon. Man sieht uns da oben auch schon.
Alles gut.
Passt alles.
Ja. Oh. Ja, die Sauer hier. Machen wir mal noch ein bisschen. Hi, Jerry, can you hear us?
Hi. Hi, Matthias. I can hear you. Hi, everyone. Hello?
I can hear you, Jerry.
Okay, thanks.
I think Matthias cannot hear us.
War leise.
Hi, Jerry.
Hello?
Yes. Hi,
now we can hear you.
Matthias. Can you hear me?
Yes,
Now it works.
Good.
let's wait a few more minutes. People are coming in.
Yes.
Wow. Okay, I think we can start. So hello everybody. This is the first community meeting this year for the Gardener project. Can you start your conversation, please? Today we have 4 topics. So the first one is Jerry will give another demo of Gardener on Alicloud. Then we have Hardik, who will talk about POC out of tree infrastructure provider integration into the machine controller manager. Then we have Lukas giving an update on the Gardener dashboard. And Peter will talk about web terminals in the dashboard. So Jerry, are you ready to start?
Yes, I'm ready.
So you can
yes.
share.
Okay. And first, thanks for Holger Crosser. He implemented the dashboard, so we could demonstrate you from end to end, from dashboard to provision a shoot cluster. And, oh, sorry. I should share the desktop here. Hi, everyone. Can you hear my? Can you see my desktop of the dashboard? That's cool. Yes. Okay. First, this is a dashboard that is run on Alibaba Cloud. I set up 2 Kubernetes clusters. One is garden clusters here. KubeGet, as you may be familiar that this is a garden cluster, and we run our dashboard, our identity service, our garden control plane on this cluster, and the second one is our seed cluster.
Jerry, can you increase the font size in your terminal?
Okay. Is it clear now? Hello?
It doesn't seem that anything changed.
No, just increase the font size.
Font size in the terminal.
Size of terminal, right?
The font size.
The letters bigger.
Font size.
Make it bigger.
It's hard to read.
Okay.
At least
font
on the
size.
beamer.
Okay, I see. Sorry.
Command plus should do it.
Okay. Bigger.
Perfect.
Now we can read it.
Okay.
Thanks.
And let's go back to our dashboard, and I try to log on my dashboard. I set up our OIDC authentication server Keycloak by myself, and try to log in. Cool, it's logged in, and as we can see, let's first check the project. I have already set up my project DCOM, because there used to be a demo in our DCOM Shanghai, and I need to prepare the secret, just like other cloud provider like AWS, and it's quite similar. Just like just need two fields. The first field, key ID. The second is the secret. It's quite similar like AWS. And after we maintained this information, we could create a kube cluster. You may notice that there is already a kube shoot cluster here, but we can create a new one. The shoot cluster.
Jerry, just a question back to the secret. The technical user in Alicloud can be limited in scope, or does it have to be in all? The IAM rights more or less can be reduced, or have you looked at that?
Actually, it's I used our RAM user. The technical user has the same authorities like my RAM user. It has IAM control, but I didn't implement it. I just use this secret to prepare my infrastructure stuff like VM, VPC, and other kinds of resources.
Okay, but it's doable. Okay, thank you.
Yeah, it's doable. We could enhance better find authorization segregations. Okay, let's continue.
There's another question in the room. Wait a second.
Yeah, Holger here speaking. So if you find out the necessary profile the user has to have in order to make it work, then you should send me the information that we include it in the dashboard. If you go back to the secrets and press the help button on the top right.
Add a button?
Top right, no.
The question mark.
The help button.
Question mark.
Yes. Then you write documentation what is necessary for.
Okay, cool. I would.
You can take a look at the AWS help to see how it should look like.
Okay, good. And thank you for your suggestion. I will follow this question later. And any other question?
No, continue.
Okay, thank you. And we just need to prepare some basic information demo. And there is only one seed cluster here, so we can only choose the infrastructure Alicloud. And the region Kubernetes version. Currently, we only support Kubernetes version 1.11 because for the CSI implemented, I just tested the CSI implementation for 1.11, and in the next month or next couple of days, we will try to support all the new versions of Kubernetes. And then secret zone. The zone and the region have the same meaning of AWS. It's very, very similar with AWS. For this region, CN Shanghai, it has two zones configured by the cloud profile, Zone B and Zone D. And the purpose, just for information. And the worker, we could support several groups of worker. Just for demo, we only need to maintain worker 1 and the machine type, the CPU, normally CPU 4, just for testing CPU 4 and memory 8 is okay for the demonstration. And the volume type, by default, we have 2 volume types, SSD and cloud efficiency. Volume size, and for auto scale information, we keep the same behavior as what is supported by AWS. For example, we can set 2. And regarding add-ons, currently we just enable dashboard by now. The maintenance. And I will click a create button. And we need to wait about 7 minutes to provision the whole shoot clusters. Before it is provisioned, I would like to explain some difference in Alicloud. The first is the cloud controller manager. By default, there's no cloud control manager implementation for Alicloud in Kubernetes. So we have a outer tree implementation. I will show you later. The second, there is no volume provisioning capability for Alicloud in Kubernetes. So we have we have an extra CSI information, CSI provisioning capability implementation for Alicloud. And the last one is because we need to provision a self-contained Kubernetes clusters on Alicloud. We enhance the DNS solution. We also support Alicloud DNS. I will demonstrate to you later. And let's see what happened after I click the create shoot cluster. First, let me check the shoot information in garden cluster. And you may notice there is a demo shoot here. It is still in provisioning. And let's go to the seed cluster. And there is a namespace created for the shoot. Get to the pod. Okay, we can see that the control plane is almost be provisioned. And let's check the Cloud Controller Manager. It is not the default Cloud Controller Manager. It is customized by Alicloud. We may check the image name. And it is add-on, and it is an image that is built by myself, and the repository is on the Kubernetes CSI project. It's a open source implementation. It works actually, and we could check because the control plane of the shoot cluster is ready. We could copy the kubeconfig to see what happened in the shoot cluster.
Can you once more increase the font size?
Yeah. Not ready. Cube get. The pod is pending. Let's see, is there an instance being provisioned? I just need to refresh.
Can you also increase the font size in the browser?
Yeah.
Thank you.
Jerry, would that all work also with international accounts?
It's a domestic account, and for international account, it's okay. Let us check what happened, because we need our. The controller manager. Okay. Machine controller manager. What is failure?
Invalid disk category.
Our colleague just use this garden cluster to do a decomp session in Vietnam today. It was success anyway. Let me check the. Let me check what happened. Did not detect any difference. No difference. Just cube getter machine deployment.
I saw something about the wrong disk type.
This type?
Yeah. Invalid disk category.
Okay, I didn't, because, oh, sorry. Maybe okay.
Maybe wrong configuration.
Yeah, I didn't use this category before to test. I try to add a new one, use default setting. Yeah. I always use cloud efficiency anyway. Yeah. Thanks for. I don't know whether we have enough time because maybe about 20 minutes have passed. Let us check the configuration for the successful one. Is there this type here? No, we need to check here. Workers. See the machine. Cloud efficiency. Okay. Cloud efficiency. This demo is not cloud efficiency.
I think you have chosen
SSD.
Right?
Okay, that's the issue. We need. If we have. Okay, please wait a moment. Disk type.
Almost.
Yeah, almost. Okay, before it is provisioning, let us check the existing one. I like to show the CSI add-ons. This is the first time we use CSI for the Gardener. Mm-hmm. It works here, actually. And I click the kubeconfig and copy paste to the kubeconfig. This is our shoot. And this is our shoot cluster. And to check the control plane, we have 3 components here. This is a set of components that works together for CSI implementation: the CSI attacher, CSI provisioner, and the CSI plugin. CSI plugins is the cloud-specific implementation. This plugins implementation is for Alicloud only. And let us try to. I would like to apply volume claim. First, let me check the Nginx example. And there are 3 kinds of resource defined here. This persistent volume claim, the deployment, and the service. And I try to apply Nginx. And we can notice there is a PVC declared here, and it is already bound here. Kube get a PV. PV, yeah, it's provision. It is added just seconds ago, and let's get pod. Okay. Okay. My colleagues use this this Jupyter cluster to do some demo several hours before. He already used the Nginx service. Okay. Anyway. Service, and we may notice there, because this Nginx service is a load balancer type, it is assigned external IP automatically by the Alicloud controller manager. And I try to click here, delete. Just a several, just more than, to delete a PV, it takes 20 seconds. Get a PV. Oh, it is deleted here, right? Pod. Service. Cool. So I just show how the PV works. It really works. And let's go back to the cluster we just provisioned before, and it seems works. And there is a control plane. Oh, Grafana is just not available by now, but I think it will be available. Okay, it's available now, and let's refresh. Oh, good. The test cluster is provisioned successfully after a couple of minutes.
Great.
Finally, it works. And so much for my today's demo for Gardener on Alicloud. And thank you for your listening and watching. And thank you for your precious suggestions.
Another one, Jerry. So
yeah.
Well enough. Could we already start to integrate that also in our dev landscape with an international account? That was the background of the question.
Sorry, international account. You just.
So the question would be that we can integrate it into our own output qualification. So, and of course, then also later, at least with an international account, have it on Canary.
Yeah, I would actually I have tested for international account. Yeah, but I don't know whether we have enough budget on international account.
I hope we can sort that out. But in principle, it would ease collaboration if we could also have access to it, and if more or less domestic and international accounts in that regard are the same, then it would work.
Okay.
Maybe it's rather a question which we should discuss internally.
Okay. Okay.
I think we also need to proceed to the next talk. We have 3 more sessions.
Okay, I will stop my sharing.
Thank you, Jerry, for the nice presentation. Hardik, you can take over now.
Sure. Okay, so I hope the screen is already visible.
Yes.
Okay, so I wanted to present the POC that we recently did for the out-of-tree infrastructures in MCM. So as it was always the case, we also had all of the infrastructure drivers inside the MCM, and now we want to basically move out the cloud provider specific code. So just there could be, I'm pretty sure there are more reasons, but I could quickly put a couple of points why we want to do that. So first of all, if the cloud specific code, if stays out, then it becomes completely independent of MCM. So basically both of the components can grow independently, and there are no cross dependencies on them. Then the integration becomes much smoother. So we had been saying that whenever a new cloud provider has to be integrated in machine controller, there is a PR on MCM, and then based on our capacity, we will review. And many of the times we don't have means of testing the new cloud provider as well. So those problems should not occur anymore, hopefully. The maintenance should become very easy. And of course, this is also part of the bigger picture where we are seeing the extensibility coming in for entire Gardener. Then the outline of the project. So what we have done is that we have tried to more or less learn from the CSI model, which is already there. So as Jerry was also talking about. So as outlined, I will quickly talk about the new projects and new projects which will be involved in the Gardener org and how they will be connected with each other. So first of all, the first project is the machine spec. So machine spec is basically a project where the protobuffer specification will reside. It basically means that the cloud it basically means that we will have one MCM as a pod running, and then we will have one external driver as a pod running, or it will be a sidecar initially. It's strictly sidecar actually. So the contract between these two components, so the message type, the structure of the message, the signature of the message, all those things will be defined inside the machine spec project. And we will version it, but we will expect this project to be not updated many times unless there is a real need of doing it. Because this is the project which will directly or indirectly affect the rest of the projects to be also updated with them. Then we will also see the new projects coming up the way there is also in the community. So we will, in under Gardener org, we will see the projects with the name MCM provider, AWS, TCP, Azure, so on. So this cloud provider specific projects will basically be the real driver implementation. And here we will see the actual create, delete, and list methods, or I would say interfaces being implemented, right? And what we have also done is that the way we had done for the entry as well, we have created one guidance. Here we have created a guidance repository actually. So you can just basically fork this sample provider repository, follow certain steps. You will see later there are 2-3 small steps which you can follow, and that will help you integrate the new cloud provider immediately. And at the end, from the MCM side, there will be few changes. So from the MCM, first of all of the entry provider code will be deleted soon. So we are planning that in the end, we are planning towards the end of the month, we will try to remove the entry code and keep only one client implementation at the MCM side, which will be the implementation which can talk to these CMI based drivers, and there should not be any other cloud provider specific code inside MCM. So that's the overall high level picture. And the design principles, so there are few things that again learned from the CSI model, and we have tried to keep in mind, or we will also expect this points to be for others as well. Whoever the new cloud provider, whoever is implementing the new cloud provider should keep in mind are first of all the kube config. So I have intentionally tried to not give access of the kube config to the out of tree drivers. So this is also a very nice point which I read somewhere in CSI, where this is explicitly so that the cloud provider specific code generally should not really talk to the actual should not really update or modify, update or create, delete or do anything with the actual machine API based objects. For example, if you want to achieve the homogeneous behavior across all of the clouds, it's better that there is a very strict responsibility given to the out of tree drivers. So for that reason, the kube config will not be given. And the next point is also in the similar line that we have for now, we have interface of only 3 methods, which is create VM, create, delete, and list machines, and we will try to keep it as lean as possible and not deviate too much doing things here and there. So we will have these three interfaces implemented at the driver side. Then the third point is about the provider spec. So the idea here is that we keep the provider spec as the basis of the entire communication. And the reasoning behind that is that provider spec is something which is basically a row of bytes. It's basically something which, from the MCM's point of view, MCM doesn't need to know what is there inside the provider spec. We will see ahead in the YAML file where it actually sits in the machine class. So basically, provider spec will be the configuration for a machine which can basically be used to create the real machine on the cloud provider. And this configuration will be a row bytes, which means MCM doesn't need to know what is there inside it, but the driver will basically be able to parse it based on the actual well-defined cloud APIs, that cloud specific APIs that that are implemented at the driver. And this will actually bring the point that I just talked about of not having the cross dependencies between MCM and drivers. So that will basically be achieved because of the provider spec. Because, for instance, if from the driver side, if user decides to update the provider spec or any of the spec inside the inside this row bytes, MCM doesn't need to care about it. Or if at the MCM side we modify any of the things, this provider spec doesn't need to be affected by that. So hopefully we will have both the components growing independent of each other. And again, after a few iterations, we decided that the MCM should basically behave as the gRPC client, and external drivers will basically behave as gRPC server. So this only means that there could be other combinations as well where you can do the other way around and stuff like that. But then we arrived with the conclusion that this is a simpler way of doing, and that's there with it. Then the next point is about the generic machine class. So till now, if you have interacted with MCM, you would know that till now we have we had different cloud provider specific machine classes as well. So for example, we had AWS machine class, GCP machine class, and so on. So we always wanted to get rid of them and aggregate to the single machine class. With this POC itself, we decided to do that. So we will not have that kind of machine classes, and we will expect that we have one generic machine class which has only one blob which is called provider spec, which is cloud provider specific, and rest of the things will be again common across different cloud providers. So that's the main idea there. And the last point, which is actually very important, and for now we will only be using external drivers as sidecar containers only. And this is mainly from the reasoning that we have not done enough investigation that if we run it as a sidecar pod, and if we plan to communicate the secrets between those components, and how whether from the security point of view that will be safe or not. But though we will do for sidecar for now, I'm pretty sure that sooner or later we'll be able to run it as a completely separate pod as well. Once we'll be confident on that idea. So, and the sequence diagram is pretty simple. If you see, there are mainly three services you can see here. Again, create, delete, and list. And the content is basically the message. So in gRPC, basically client and server talks to each other via well-defined protobuffer messages. So this create machine request and create machine response is, for example, two messages which will be used for the creation of the machine. And the details that we are always migrating between them is mainly the provider spec and the secrets. And secrets here are not encrypted as such as of now. And that is the reason that we want to keep it for now the sidecar. But we will see the possibilities how we can better manage them. And similarly, we will also have the message structures for delete and list machines. And so there is no as such demo for it. Just that it's the experience for the user. The experience will remain same. This is more from the developers' point of view. The change has been made, but the machine spec repository has already been migrated under Gardener. And here, if you see this is very small and lean project. It has only one file, which is the most important, which is the .proto file, the cmi.proto. And here you can see that we have defined the signature like create, delete, list, and we will also probably define the stuff like get capabilities and so on. And we expect that this signature, once we decide, we don't modify quite a lot, so that the other components does not have to keep adapting them. But so that's one new repository introduced, and the other new repository which I was talking about was the sample provider repository. So here, basically, this is the repository which you can just clone, or I would say which you can just fork, and then you can make certain changes in this repository by following a very small set of steps. So here the code changes requirements are only this much. So you basically once you clone this repository, you basically take the provider spec. So provider spec is something which is the APIs for the different clouds. For example, here there is a small example of GCP. So if you see for GCP, previously we had this spec defined inside our inside MCM's API itself, but now those API will come out from the MCM's API and they will have their own separate place. So here, for example, GCP-based APIs are defined, and this is at the driver side. So it is expected that user basically defines their provider spec. Then the main method, so the main file which needs to be updated is the machine server file, where we actually implement the create, delete, and list methods basically. So for GCP, you can see that we again have a create machine method, which the only job of this machine method is to talk to the cloud provider, create the machine, and give the right kind of code spec. There is no other responsibility of checking what's going on with the Kubernetes or what's going on with the real machine objects and so on. So, and these are the same. Actually, the methods are also exactly same the way it was previously for in the entry. So we could just copy those set of methods and put it here with very small glue code in between, and that should work. So, and of course, you will have to re-vendor it at the end. So re-vendoring is this will also help us in many ways, where previously, because of all the cloud providers, vendors had interdependency, we many times ended up into the vendor hell. But now, because the cloud providers are going out, we will see less vendoring issues here and there. And finally, on the MCM side, the status at the moment is that we have not integrated this into the master, but we have a separate branch called CMI client. And the CMI client branch, right now, the integration is more or less working with the drivers which I just described. And we are hoping that nearly at the end of the month, probably we will be able to basically make the driver look something like this, where previously previously you could see that here there were a lot of cloud providers, but we will have to remove it. So that was also the reason where I have recently requested Jerry and as well that if they can also look at the provider implementation and see if it makes sense for them to implement for it. Because the reasoning is that from the master, then we will have to at some point remove the cloud provider specific code completely, just to not lose them from the So now going towards how the new spec will look like. So from the machine deployment point of view, there is really not any difference. It will look exactly the way it used to look, just that here we will have a new, we will make kind equal to machine class, that's all, instead of we had very specific cloud specific machine classes. And from the machine class point of view, we have in the machine class, if you remember, we had only spec defined here, and all these things were, I would say, typed inside the MCM, which is not the case anymore. So now this will become provider spec, and this is row byte. So if you give any chunk here, MCM point of view, it will not basically parse it. It will just blindly take this part as a row byte and give it back to the driver, and then driver has to decide whether this is the right spec or whether there is something going wrong here or not, and give the right kind of code spec. That's the overall idea. And from the demo, there is nothing new to show. All the features of MCM will work as it is, as they were working. It's just, I can quickly show something. So here I'm starting the machine controller manager itself. On one side, so I have created one cluster on the Gardener dev landscape, and this points there. So I have created one cluster. So I just started the MCM here, and I can also start now so you can already see the error that it is not basically able to find the driver. So once I start the driver here, Okay, so I have started the driver on one hand where you can see that it's basically running on the local host only, and MCM will also basically try to contact the local host all the time and expect that at certain endpoint it will be able to file the certain driver. And here is just the node objects they are described. I can quickly do the apply. Apply of the machine deployment, which we just saw, and it just basically does the same thing. MCM picks that up, makes the right kind of calls to the driver. Driver creates the machine, gives the right response back, and the flow, the remaining flow just remains as it was previously. And I can probably make small changes here and there, make it 3 probably, and stuff like that, and it should scale it accordingly. And here, what we can probably see also, just for the sake of verifying, is that we can do the get machines again. Get machine shows that there are 3 machine objects created. Get machine set will show you that there are 3. There is a 1 machine set, and machine deployment was anyway there as it should be there. So in a couple of minutes, we will see the real machines joining here, and then we can eventually delete the node objects. We can delete the machine objects here. So till then, if you have a question or something for 1 or 2 minutes, we can discuss that already.
Any questions?
So at the moment, Avi from Packet implemented it in tree, right? Is there?
Yes.
Are there plans to get it out of tree? And if yes, is it out of tree under the Gardener project, or will it be under which repository shall be used? Have you aligned on that?
Okay, that's a good question. So it will definitely become out of tree, but I have not really aligned with him that whether it will reside under Gardener or so outside. We can discuss that separately. I don't have any strong opinion on that, but it can either place.
Is Avi on the call?
Technically, it should. Doesn't seem so.
Okay.
Okay, but it's a good point. I'll check with Avi, and he already knows that we are doing this out of tree, but I'm not sure whether he wants to put it inside Gardener. Let's see. So that's pretty much all I would say from the demo perspective. If you delete the machine deployment, it will basically drain the machines and delete them one by one.
Perfect. The way out of tree is happening. Good.
Thank you.
Yeah.
Can you unshare, please?
Yes.
Okay, so the next session is Lukas with an update on the Gardener dashboard.
Okay, yep. Can you hear me? Can you
Yes.
see my screen? Okay, perfect. So
And as usual, increase font size, please.
yeah, I can do, but this will probably break the UI. Okay, so yesterday we released Gardener 1.27, and there are quite some improvements and features included. So we already saw the Alibaba Cloud support, but we also did some other things. We improved the search. So previously it was only, you were only able to search by name. Now you can also search, for example, for infrastructure, kind or name, and then also for things like version. So you can easily find clusters and a specific version, infrastructure, also able to search for purpose, journal labels, or even created by and project name. And also you see here on the bottom that we included client-side paging. So the reason for this is that, for example, on this landscape here, if I show all clusters, we have less than 200 clusters, but still the previous dashboard versions ran into performance problems here on this all cluster list. The reason for that is that the client-side rendering of this table is, needs a lot of CPU power, and so we decided to show only 10, or you can specify up to 20 clusters per page, but this is only for the all projects view. If you are in a dedicated project view, you will see all clusters on one page, independent on how many clusters are in this project. So this is mainly for operator reasons, because we now have landscapes with a large number of clusters inside. So then some other small improvements. Let's quickly go into a shoot. We now have here at the top the name of the shoot. So previously there was only shoot details in this instead of the name. So if you are, for example, on the YAML editor and you have multiple tabs open, you maybe were not sure on which shoot you're working. So now you have it clearly visible. Then we did some fixes to the sorting of the versions in the cluster list, also the readiness tags. There were some small issues. Then we fixed some issues with the alignment on the help menu up there, and also included the backend version of the Gardener dashboard, and also the API version which of the Gardener, which this specific installation points to. Okay, then some other pop over and alignment fixes, and yeah, then we had some contributions regarding our Helm charts. So you're now able to specify more values there. And then we updated Vuetify, our front-end library, UI library, to the newest version, which also fixes some issues. And then, yeah, we had a problem with the general information banner. So it's possible to specify like an information message in the Gardener dashboard configuration that appears on top of the page for like announcements or to indicate issues with the landscape or something like that. And this feature, I think we broke it some releases ago. I don't know when exactly, but it did not work anymore. And this is now also fixed. And then, yeah.
One question: why you Kibana? Was it by intention or?
Kibana? But I skipped it. No. So we now show the Kibana logging stack URLs and also credentials on the cluster details page. Yeah, here you can see it. Okay, then we had, this is more a specific problem, but if a cluster has reconciliation deactivated with the ignore annotation, and a user now tries to delete this cluster, he will get a warning message in the deletion pop-up, which indicates that this cluster will not be deleted until this ignore flag or ignore annotation is removed, because without the Gardener reconciling this cluster, it will not be deleted. So this is just an information so that the user gets informed about it. Yeah, and then we support or fully support the progressing state. This was introduced in the last Gardener release, and we show for operators this progressing state, the nodes in a blue color, so that it's not too much attention for it, but you can see why these clusters pop up in the, or show up in the all clusters with issues list. And for users without the operator role, we do not show this this color or do not show these clusters in the shoot with issues list. So it's only for operators. I think, yeah. So the last 2 points are basically also support for the community to support other other OICD OIDC providers, and also I think it is a workaround, right, Holger, for the cause problem on Azure. Yeah. Okay, that's it for the very quick update. And now Peter gives a, yeah.
Just a minor comment, cosmetic one. Maybe we change access and monitoring so that access is first, then comes monitoring and logging.
Yeah, makes sense. Yeah. Okay, then I answer so that Peter can continue with the terminal preview.
Okay, so I will show the operator feature. So the idea is that an operator can look into the, for example, control plane of a shoot or at the shoot directly by having a web terminal inside the dashboard. So there is no need to have it to download the kubeconfig and configure your kubectl locally. So I will give a short demo on this, but before I do that, on the right side, I have opened the terminal so we can see what is happening on the seed in the shoot namespace. So
Peter,
here
can you increase font size?
I have already increased it, but I can increase it even more.
Yeah, that's better.
Yes, okay.
Yeah.
At the top, we see the service accounts in the namespace of the shoot on the seed. And at the bottom, we see the pods of the control plane. And what happens now when I go on or access the terminal tab, we see here it's a loading indicator, and on the right, if you saw it, there were 2 new service accounts and 1 pod that we create. So we have a service account, we call it attach, so that we are able or allowed to attach to this pod that we create here, and also we have a service account for the control plane, so that we can fetch and we can configure the kubectl inside this pod that we create. So the connection is there, and we have also the kubeconfigs available for the control plane of the shoot and for the shoot itself, and it resides under TMP currently. So kubectl is currently configured to work with the control plane. So kubeconfig, and you see the same as I have here on the right side. But we, like I said, currently we have both kubeconfigs inside this terminal pod, but we are currently thinking about splitting that. So either you have 2 terminal tabs, one for the control plane, one for the shoot, or we have a split pane. But yeah, if you have nice ideas on that, you can also give us feedback here. And we also have a reconnect feature. So either if the connection is lost or if the process, the bash here is killed, for example, if I exit the bash, then it will say that the connection is lost, and you can retry or close it and maybe copy some stuff here. And you can see here also there was a restart of the terminal pod. And on retry, I'm again connected. And yeah, how we set it up currently is that we create one pod per admin user and per shoot. And if you have stayed here and switch to, for example, members section and go back to the cluster inside the terminal, you are attached to the same pod and session. And yes, that's it. Any questions?
So how do you actually handle? I mean, so what's about garbage collection? So if
okay, so yeah, I haven't mentioned that. So so I am not sure if I mentioned it, but it's still work in progress. But the idea is that we clean up. So we have a job scheduler running, and which will clean up the resources that were created. For example, if so, all the resources that were created have an owner reference on the attached service account. So the cleanup job has to delete this one, and it will delete all the other resources that were created here. So this can run periodically, for example, or it will clean up if there is no heartbeat for more than a day, or you can say also for 5 minutes. Doesn't matter, but yeah, we will clean this up.
Yeah, okay. So the idea with the heartbeat is that the browser sets an annotation on the terminal attach service account in, I don't know, every minute or so, and sets a timestamp there, so that the cleanup script knows where which pods or where or service accounts had no heartbeat within like 24 hours or so, and then we clean them up. So that's the idea currently.
Yeah, and also some technical details on how we did it. So we had several POCs and where we, for example, did the connection. We channeled it through our backend and then attached to the terminal pod. But now we do a WebSocket connection directly from the browser and talk to the Seeds API server to attach to the pod. So, yeah, and for that, of course, we also need a valid certificate on the API server, and yeah, therefore we had to create an ingress for the API server on Seed. So yeah, and like I said, it's still work in progress.
Thanks a lot, Peter. So this ends today's community meeting, and we see the next meeting in 2 weeks. Bye-bye.
Bye.
Bye.
Very good, thank you.
so.